Wait a minute. I handle architecture and API platforms at a very early stage startup called DevRev. I'll introduce the topic briefly before introducing myself because I want to introduce myself in the context of the topic, and very soon, hopefully, it'll make sense. But today we're going to talk about the different roles within software engineering. We'll start off by asking ourselves why, like, why do we even care about knowing about the different roles, or why should we know the differences? And then we look at a bunch of these different roles. Now, this is by no means exhaustive, so it doesn't cover every single role out there, but it's representative. And what I mean by that is we're going to look at this in the context of a product stack and how different parts of our product stack actually map to these roles. So we have a bunch of these roles that we'll walk through. And then we'll end by asking ourselves how we can start exploring these different roles without waiting to be hired by a company as such, and then open it up to Q&A. I think Harini did call out the disclaimer as well, but the session might be a little heavy in terms of content on the slides, but I will try to make sure that we talk through everything, and I'm happy to pick up questions at the end of the session as well. There are some acronyms, so if any of those acronyms don't make sense, please do post your questions on the chat and we'll make sure that we address those. And I must state that, yes, instructors don't know anything. I certainly don't know everything. So if I do not know the answer to any of your questions, I'll make sure to go back, look it up, and then answer you at a later point. So this is more about the backend engineering study group itself. So at a very high level, this is where the backend engineering fits in terms of the browser is what is traditionally viewed as front end, and the web server and the database portions are viewed as backend, and there are some terms. So this is broadly what applies to this group, but we will quickly take a look at a little bit about myself before we go ahead with today's topic. And the reason I wanted to kind of talk through a few parts of what is shown on this pretty crowded slide is because I think it's relevant to the fact that we're talking about all of these different roles. I do want to point out that I haven't played every single role that I have listed in the presentation. Some of these roles are just roles that I have observed. I have worked with these people closely who have played these roles, but there are a wide range of roles that I have been fortunate enough to play myself. So I started off in the embedded systems and the radio frequency space. I basically was working on building networking, switch infrastructure, and then I built radio frequency transceivers for mobile phones, did some work on Wi-Fi and Bluetooth technologies, and then I worked on building a security and cloud networking product, API gateways, load balancers. The idea behind just listing all of these is to say that some of the roles that we're going to discuss, I can kind of give you examples from my own experience to tell you what the role was like. And I have also worked at a range of different sized companies. And the reason I feel this is kind of relevant to mention in this context of this presentation is the roles actually vary depending on whether the company is a big company or a small company. So even though it might be called the same, what you're doing in the context of that company would actually differ. The other piece that I want to point out is I do host a podcast on career choices. And this podcast is more about, I bring on people from different industries and different roles within the industry to talk about their career choices and decisions and point out how some of their decisions played out. And the reason I find that interesting is we don't have to all make the same mistakes to learn from them. So we could very well use some of the candid accounts that many of the interview guests actually share. So moving on to today's topic, I'll start with the why. I think it's always useful to ask ourselves why we want to learn something or why we need to learn about the different roles in this case. I found this cartoon extremely intuitive, I mean, extremely appealing, actually. It's not in the context of roles. The original cartoon is in the context of equity and freedom. But it makes a very interesting point. So if you look at this cartoon, it shows a set of different animals. And then we're talking about how fair selection is everybody passing the same test, which obviously is not fair, because even though it's the same test that's applied, you're not applying it across to people who have equal skills, right? So why does this, how does this even fit in the context of the roles that we're talking about? Even though all of these roles require coding and they are broadly categorized as software engineering roles, they all have different challenges, different skill sets that are needed. And you also have to probably be interested in a different area to appreciate different roles, right? So the idea behind talking about these different roles is to see how do we choose a role that best suits our interests? And then also, how do we kind of map this to the product that we want to build out? So depending on which part of the product you're interested in building out, a different role might actually be more suitable. So I want to kind of talk through the different roles from the perspective of the product architecture. So a typical product is basically laid out in a certain fashion. Now, of course, depending on the actual product or the actual application that you're building, there will be a lot of differences and variations. But for example, in this particular diagram, what's called out as application logic is going to be completely different depending on the exact application that you're building out. But the generic framework of what makes up a product could be shared in terms of the structure. And so generalizing to that extent, we can assume that whenever, let's say we're building a website powered by some application logic, we want to be able to make sure that our website is performant, that it's able to handle a lot of traffic. And to be able to handle a lot of traffic, one of the constructs that's used is a load balancer. There's also a construct called a web application firewall. Now, this is something to make sure that you don't have malicious traffic or a security attack on your website. So how do you filter data and how do you make sure that only legitimate traffic actually reaches your product? So there are a ton of more constructs. I'm not in the interest of not getting pigeonholed into the exact technologies. I haven't listed all of them. So there's a caching layer that could be there and so on. But this layer broadly is what an infrastructure engineer works on. So now in the context of this, now given that we know where in the product stack we're focusing on, we'll talk about what an infrastructure engineer actually does. So an infrastructure engineer, very broadly, is responsible for maintaining and building and coordinating and running operations of everything that's internal to your company. Now, this could broadly be categorized in many layers. So if you think about just the software, how do you actually deploy the binary or the logic that makes up your product? How do you take care of software load balancers and caching, right? Just to clarify what caching is, it's just a way to speed up trying to serve some kind of data on your website or basically serve data. And then there could be something called microservices orchestration, which is trying to say, okay, so you have a lot of functionality built into your product? How do you break it up into smaller pieces and make it possible to run on the hardware? Now, there is the networking layer. So we spoke briefly about web application firewalls, but firewalls in general, it's a construct to keep out malicious traffic or unwanted traffic from your product. Routing and switching is a way to actually communicate between different places. So different parts of your product, or it could be your product communicating with the broader internet. Now, the last one that we're talking on this slide is the hardware layer. Right now, I guess we have a lot of these systems running on cloud, on the cloud, whether it's AWS or GCP or Azure, which essentially means that the hardware layer is maintained by these cloud vendors, and the infrastructure engineer just manages the interface to that cloud. But you could also have more traditional companies where you actually maintain your own data centers. You have your own hardware. You actually, and very soon we're going to hit a role where we'll actually unpack that and see what that hardware looks like. But that is also something that would come under the purview of an infrastructure engineer. This slide is essentially just to make a point, not that I'm going to go through every line of what is there on the slide, but the point is that this is from LinkedIn, the source, and it lists a bunch of job ads by these different companies for an infrastructure role. And you can see there's a little bit of variation, but there's also a lot of overlap in terms of asking for cloud certifications, in terms of asking for certain language skills and database and so on. But broadly, to sum up, an infrastructure person is someone who tries to piece together all of these different parts to make a system operational to build a product on. So we are now moving further in the stack, right? So we had this one infrastructure layer, which is taking care of, which is making sure that we're getting traffic to our product, we are getting secure traffic, and we also have it balanced out so that our website's not going to crash, right? But then how about the web UI? So we're now talking about the point that the traffic has reached your website and they are looking at the user interface. This is something that the front-end engineer deals with. So building a website, so I have this example page, which is shown on the left-hand side. Now, I firmly believe that the best way to understand any role is to actually play with aspects of it that you can try yourself and experience. So this picture that I have chosen is from an open source project called Stoplight Elements. So I have a link over here. You can go to the website. So you can go to the GitHub link and view the, so this is the entire code, of course, which makes it possible to build that website. But there is a mechanism for you to actually run this locally on your machine. So I highly encourage you to go to this link and bring up this page on your own machine. And what that will let you do is it will let you inspect this website. And also, if you're curious enough, you could see how you could build part of these website. So the power of open source is you can actually correlate and see. So for example, if you want to see how do you build this to-do list, or how do you build this slab out here, you can actually see the code that's corresponding to it. I know this might be a leap too far for someone who's just trying to start out and figure out what front-end engineering is all about. So let's take a step back and just talk about a few very high-level terms, right? So one high-level term that you'll notice is HTML. You'll see this everywhere where there's anything to do with front-end engineering. So that's hypertext markup language, and it's the language that's used to build websites. what you see over here is on the left-hand side, you see what is HTML. So this is how HTML looks. And on the right-hand side is the output when you run this HTML. This is again something that I would encourage you to try. So if you click on this link in the slide, it would take you to a place where you can actually play around with it. So I encourage you to just, so for example, let's say I change this and run it, you would see the output over here. So you can make this as complex as possible as you get more interested and want to play around with it. And then you can see the output of what you've created. The other concept is something called cascading style sheets or CSS. And this is used more to format and provide the look and feel of your website, the colors, the spacing, and the background color and so on. So this is again something that you can try out. So you can click on this and you can play around. So the code over on the left-hand side produces the output on the right-hand side. So you can play around with the colors and you can try it out.
Ashwini,
sorry.
Sorry to interrupt. I think this time there is some glitch in the way how they have set up our Zoom sessions, because now it's saying we only have like 6 minutes and 45 seconds. Yeah. Looks like at the end of 30 minutes, we might get kicked out. So in case something like that happens and we can't continue, we can schedule like a follow-up session for this. So you need not rush through, but just letting everyone on the call also know that we might get kicked out in another 6.5 minutes.
Sounds good. Yeah, thanks for that heads up, Harini. I'll probably just do 2 more roles and then stop for now then.
Debbie is asking if we can rejoin. We can try that. If we get kicked out, we can all try to rejoin the same link. If it works, we can continue. If not, okay. Prachi is saying rejoining should work. So let's all, even if we get kicked out, we can rejoin the same one and continue then. Thank you.
Perfect. So to basically summarize and to go a little deeper on what a front-end engineer does, it's of course building the website, but also thinking about it from a usability and a user interface aspect. And this piece kind of often gets ignored, but you also need to monitor the website and ensure that it runs properly. So building is the first aspect of it, but you also need to maintain the website, make sure it's performant, so on, right? So also thinking about those aspects. The other interesting thing is that whatever you design for a web, you should think about how that would work on different devices. So making it work on a smartphone may not be automatic because the display dimensions are different and so on. So those are some things that a front-end engineer does on a day-to-day basis. Now I have this piece called Interview Corner. Again, a disclaimer, it's not a comprehensive list of things that you need to know to crack an interview for a front-end engineering role, but it's a hint on things which are deemed most important. And that basically is the HTML, CSS pieces that we just discussed, but it's also the coding aspect. And as far as the coding is concerned, the JavaScript and the React, the couple of slides earlier, the link that we had to the open source repo, that will give you a good sense of what kind of code a front-end engineer actually develops. So let me try to cover one role before we have to rejoin. The next role is the backend engineer role. And this is the immediate next part of our stack. So once you hit the UI and let's say you receive a request. So if you take a concrete example, let's say that there was a button on the UI which got clicked, and then you had to send an email to someone in response to that button click. Then you have to communicate the fact that the button was clicked and something needs to be done to a backend server, which is called an HTTP or an API server. An API is basically an application interface. So it's just an interface to talk between the UI and a server. And then there is application logic, which basically will translate this to say, hey, I want to perform this action. So let's say I want to send this email out, right? So let me take a few examples in terms of what a backend engineer could do, right? Again, keeping with the philosophy of let's try it and let's experience it, I would highly encourage people to copy what is on the left-hand side of this slide as a server example. And you can run this on your own local laptop. What you will see, and again, I must say, this is Golang code. So this is just a language that I'm comfortable with that I chose, but you can actually choose different languages. When you run this Golang code, you will see that it prints starting up a test server, right? So the server aspect is what we focus on in backend engineering. Again, this is a very simplistic example, so I don't want to mislead people to thinking that this is all that a backend engineer does, right? And so I have a slightly more complex example on the right-hand side, which is these chatbots. So typically, if you go to any website these days, you will see a chatbot that would come up and be like, hey, are you looking for something? Can I help you? So all of that could be, is powered usually by some backend and application logic as well. So what does a backend engineer do on a day-to-day basis? Yes, of course, we do write software, but it's about building robust and scalable software. What do I mean by that? Things that don't crash and things that can handle a lot of traffic, right? And then design and create these services and applications that we spoke about. There is also an aspect of testing, which is actually part of every role, but I guess I should have called it out in the front end as well. But we will also look at a role that's exclusively focused on testing, apart from it being part of every other role of development. There's also a fair bit of design thinking that goes on. So you would have to talk about, you would have to coordinate with the product and the design team and the architecture teams and so on for use cases because you're building an application. Again, the interview corner is just an indicator, but knowing about HTTP, knowing about server development, databases, operating systems. Now, the coding languages are kind of just, you'll see a whole bunch of them here, and there could be more as well. It's just an indicator that backend engineers actually can program in a wide variety of different languages. Excuse me. The next one is systems software, right? Which is kind of a little bit different from the kind of roles that we've discussed so far. Oh, Harini, do you want me to stop at this point? Because I think it says less than a minute.
Yeah, it says less than a minute. So maybe.
Got it. Perfect. All right, sorry for the interruption. So getting back to the system software role. So the system software role, let me quickly talk about it. So at a very high level, we have like three major constructs which make up a system. So there's storage, there is compute, and there is network, right? So storage is typically someone who's working in the storage area would work on things like file systems, caching, again, a way to serve up data quickly, and then focus on things like, how do I make reads and writes more performant? Like, how do I make it quicker? How do I make it more effective? And how do I make it less error prone? And then there's the compute angle, which is like, how do I optimize the performance? How do I do different kinds of process scheduling, which makes it more efficient? There's the network aspect, which is about, of course, connectivity, but it's also about like, how do I optimize the bandwidth? How do I save on costs on all three, right? So a systems engineer clearly looks at it at a different level compared to the other roles in the stack that we spoke about so far. And one way to think about it is it's closer to the hardware, right? You will see a layer between them, and there are probably multiple layers. This is a very simplified stack diagram, but the software person is more aware of the actual constructs of the hardware and managing them. One thing that I think I didn't mention specifically in any of the roles so far is the database piece that you see over here. I have kind of not spoken about the roles which are to do with data, essentially for brevity, and also because I haven't worked on those directly. But there is a huge, basically a number of roles focusing on optimizing databases, on analyzing the data in a database, building pipelines, and so on, that we will cover in a different session. Now, coming back to the system software, we said, yes, it's you need to understand these aspects. It's closer to the hardware. So you need to understand computer architecture for this. And you need to think closely about operating systems, like in terms of memory management. There's a construct called virtualization, where it's essentially sharing the same hardware, but then bringing up different instances for consumption by the higher layers. And then thinking about networking protocols like TCP/IP or different other lower layer protocols as well. Now, of course, you have to code as a systems engineer as well. But the coding language that you see over here, it could be C, C++, Java, which, and I want to point out one critical difference over here. So the difference between programming at this layer and any other higher level language is that you have a closer, or you have more of a control on things like memory. So to give you an example, and please, if any of this sounds like jargon, or it's too much, I mean, if the concepts don't make sense, please post in the chat and we'll address it. But there is a construct called garbage collection. So essentially, when you take some memory, so you allocate some memory, and then you're trying to use it. And then at the end of using something, so you allocated this memory, let's say you're doing something with that memory, you're writing to it, you're reading it, and then at some point you stop using it. You have to ideally return it back to the system so that that memory can be provided to someone else, some other process to continue. And if you were to use a language like C or C++, you would have to do this manually, and you would have to keep track of it. And you have constructs called pointers, for instance, which make it necessary for you to actually operate on these memory structures at a granular level. A high-level language, and Golang, for example, has something called garbage collection, which just takes care of this for you, right? So you don't have to actually keep track of this or do it manually or things like that. So there is a level of control which is higher with these languages, but it also makes the programming a little bit more complex. So along the lines of the systems engineer, so today, most systems are distributed systems. So what I mean by that is you don't necessarily run your program or your application on one machine. You probably run multiple instances of your program on these many machines, and then you treat it as if it's one, right? And what I mean by that is your application, the fact that your application is running on 4 different machines shouldn't change the logic as far as you're concerned. So that naturally means that there is some layer in between, which is doing this magic for you, right? And that is commonly known as middleware, or the layer that a distributed systems engineer focuses on. Now, this interview corner has a lot of jargon. So I will try to explain at a high level few of these terms. But again, it's not an exhaustive primer on distributed systems, but I'd like to hear if anyone's interested, we could do a dedicated session on this. So there is a concept called consistent hashing. So the idea is when a request comes, we briefly spoke about load balancing, right? Like load balancing is a construct where, let's say a request comes and there are 4 servers, you decide which server handles your request, right? So the simplest scheduling mechanism is you just say, okay, there are 4 servers, I'll just send it to server 1, the next time I send it to server 2, 3, and 4, and so on, right? But then this becomes complicated with distributed systems because you want to handle the case where one of those systems just dies, right? So the logic to make sure that you have like a fair load balancing system, given all of those constraints, is called consistent hashing. There's also another concept called consensus protocols. So like we said, again, you have multiple of these systems which might be running the same program. So you want to make sure that if any one of them fails, the overall state of the system actually remains fine, and it's like they can continue operating as if nothing changed, right? So consensus protocols is a way to do that. Like there is logic to ensure who writes, who becomes, there is a construct called a leader. So they figure out who has to actually take ownership of the request if something goes wrong, and so on. There's also read-write consistencies. This is about, hey, I want to make sure that I know the exact state of the system, but I don't want to delay you in terms of how long you should wait before I can call a write complete. This might seem too high level again, but this is just to give you an idea of the kind of problems that a distributed systems engineer thinks about, and we could deep dive if anyone's interested. So moving on, now we're going even closer to the hardware, right? So we're going into the area of firmware engineer. So firmware engineer is someone who works really close to the hardware. So this is almost directly controlling the hardware. So to give you an example of what a firmware engineer does, it's writing a cellular modem or an RF device driver. Like I mentioned, I've done this in the past at Nokia. So that's why you see a bunch of Nokia phones that many of you may not even recognize, might be too young to recognize. But writing logic that makes it possible for you to make a phone call, right? Or an actual call to somebody requires being able to control the hardware circuitry. Now, this diagram might seem very kind of complicated, and you're like, what is this diagram, right? This is actually a diagram which talks about how your hardware circuit is laid out, but the firmware that you write controls these components. So it's a digital circuit, so it actually has a bunch of it has a bunch of bits and registers, and these registers map to some functionality, whether it's like turning on the antenna switch, or it's trying to change the frequency, or it's trying to maybe control the power amplification. But how do you actually write logic that controls the hardware? So one thing that must be evident by now is that firmware engineering requires you to understand the hardware, the board layout, understand how things are actually working in the hardware before you can be a firmware engineer. So the complexity doesn't lie at the algorithm level, but it lies at the system design or the hardware design level. So taking our example further, it could be about writing these pieces of software called device drivers. So they're actually it's actually the software that drives the device forward, right? And you would do what does a firmware engineer do on a typical level? It's like there are activities called board bring up and upgrades. So every time you have a new hardware board which is out, you would have to make sure that your firmware can bring this board to life, and that's called a board bring up activity. I did want to also mention a few examples of firmware engineering in the context of what's relevant today. So there's Internet of Things, which is essentially if any of you has a thermostat, a Nest at home, or a camera that's controlled by software, which is or an intelligent light bulb, all of those fall under the Internet of Things. And then there is the whole modem software for 5G, which is also something which involves firmware, a lot of firmware logic. So at the firmware level, you would be definitely programming, not even in C++, most of the times probably in C. So you have to have a good grip on computer architecture. So one thing that's different between firmware engineering and the rest is you're working with very constrained resources in terms of compute memory. So you need to be very efficient in your programming. So we have now covered the stack as such, but what about somebody who does all of this together? And that's a full stack engineer. So somebody who can put all of this together and build both the website and the logic that makes the website work together is called a full stack engineer. They're usually people who also have a certain amount of design and architecture responsibilities, along with having to implement these different pieces. Now, there are roles which are actually applicable across all of these layers of the stack, right? So we'll talk about those very briefly. Again, this is a role that I only know by association, so I have not been in this role, disclaimer. But typically what a quality assurance engineer does is developing these test plans and test automation, and actually executing that automation or the manual tests, and then reporting the quality of a product. Now, why is quality assurance important? You want every product to be of a certain quality by the time the customer is using it. So somebody needs to be able to gate it and make sure that it's actually at a point where the customer can start using it. And that's the role of a quality assurance engineer. Many of these roles have basically been, they overlap today and they have been merged into different functions. But there is still a role for quality assurance because you need somebody who is outside of the building to be able to critique the product and certify the quality. So there are a bunch of different kinds of testing. So there is something called load testing, which is about performance. There is functional testing to actually make sure that the product works. There's smoke testing to make sure nobody breaks the other person's logic. There is performance. So there are different kinds of performance. There is the context of latency, how responsive is your system versus the load, versus how much of traffic can you handle. There is security testing to make sure that your product cannot be attacked, or at least is not prone to attack. And then there is API testing to make sure that your interfaces are usable, and end-to-end testing. So in terms of the interview corner, understanding these different aspects and being able to code and script and understanding test frameworks. We're going to talk about one example. So this again is open source. So again, encourage you to go take a look. And this snippet is to just give you an idea of what test framework looks like. I mean, it looks like familiar code, and it's it's basically using the same language constructs, but it's creating a test framework. So you can play around with it in this location, on this GitHub location. The next role that we're talking about is DevOps. I don't know. I think we lost the connection earlier before I could answer the question. Somebody had asked, what is the difference between infrastructure and DevOps? So I can address it now that we're talking about DevOps. So this is a relatively new role, and it is at the intersection of many roles. So we spoke about development roles like engineer, backend engineer, front-end engineer, so on. We spoke about quality assurance. We didn't speak specifically about operations, but operations is to make sure that your app or your product is up and running. And what happens when it fails? Somebody needs to take care of it, make sure to reboot it, for instance, and so on. So that's operations. A DevOps person does a little bit of all of these things, right? So I've listed a bunch of things that a DevOps person does. It's around automating software. CI/CD pipeline is a development mechanism. Like how do you develop, how do you test, and then how do you deploy your code? How do you scale? So you've written an application that runs on one system, maybe. How do you make it run on multiple different systems? How do you manage data, network automation, and so on? So now the difference between infrastructure engineering and DevOps is infrastructure engineering. As you know, we spoke about many of these fundamental constructs which are applicable across the entire company or the product, right? And they are kind of foundational aspects. They might be hardware, they might be software, and they could be networks as well, right? Again, either controlled or built by you or external users. On the other hand, DevOps is kind of focused on whatever you develop, how do you operationalize those aspects? So this is more about in the context of your product. So focused on the deployment of your product, the incident response, monitoring, and so on. So in terms of the interviews, of course, it might sound very similar in terms of deployment pipelines and certifications and so on. But there's also the ability to write something which is called infrastructure as code, right? And we will briefly look at that. This is an example. So there is configuration that is written in the form of code to deploy the product or deploy the software or the application, right? And YAML is the format that is chosen for it. So there's an example over here. Again, this is publicly accessible. You can go to this link and check it out. So there's something called a Helm chart, which is what assists users in defining and installing and updating. So you'll see that I mentioned something called Kubernetes over here. Again, won't get into the details of Kubernetes, but it's basically a system for handling distributed, virtualized software. Now, the last role that we're going to talk about is a security engineer. Again, something that's applicable across the stack. And this is more of a role which is auditing or checking or making sure that your product doesn't have any holes, right? So you're trying to make sure that you can identify the security measures, and then, I mean, God forbid you do have a security incident, you need a plan on how you're going to tackle it. They would run a bunch of different audits and compliances to do everything that's required for that. There's also this aspect of identifying vulnerabilities. And this is, there are many tools out there for this, which you can either integrate or build. There is threat modeling, which is very interesting because you're trying to now simulate or identify scenarios which could actually be threats based on your own system architecture or application architecture. And then there is detecting attack vectors. So fuzzing is a concept where you actually can inject your application with these, random data and try to introduce attacks through those tests to simulate and see how your software behaves in different conditions. So the interview corner, of course, has pretty much what I just mentioned in terms of the role itself. But this is an example of how you could view a threat model. So you will see this nice diagram over here, which is generated by the code on the left-hand side. And this is about building out the architecture and the connections between the interactions between the various components in a system to be able to identify and model threats. So if anyone's interested in knowing more about this, this is again an open source repo that you can go and look up. And you can get this code and download it and then generate this diagram. And again, you can play around with it, change the code and see how the diagram changes and so on. Now, the last aspect of it is we said that we're also going to try and find out how we explore these roles further. And these resources should help you do that. All the repos and projects that I've listed over here are open source, which means that they give you the opportunity to play with them. And then I've also thrown in a few of the interviews, which I think might be useful in giving us more insight into the role itself. You can reach me on LinkedIn or on my email, and I'm happy to answer any questions at this point. I think before I conclude, let me take any questions.
Yeah, I've allowed people to unmute. So if you have any questions, feel free to unmute and speak up.
I think I see one question from Olga about ML engineers. Right? Okay. So yeah, you're right, Olga. And the thing with ML engineers, I think I kind of moved it out because I felt it fit more with data engineering, but I can kind of briefly talk about that role. So with ML engineers, it's so machine learning as a topic, it basically has several roles. So there is an aspect of machine learning which involves a data scientist making decisions based on the collected data. There is another aspect of machine learning which involves modeling based on that data and having predictive and analytics and making inferences based on that, which is the modeling role is extremely technical, and it requires a lot of understanding of the theoretical aspects of machine learning and probability and statistics. And then there's this other role called ML engineering, which is more about how do you actually make it possible to run these models. So it's great, you've come up with this whole model, but then you have to actually run it somewhere. You need to be able to operationalize it. And that's where the ML engineer or the ML ops person comes into the picture. So you will be responsible for figuring out where to host these models, how to build this pipeline to make it possible to build the model, deploy the model, iterate on it, and so on. So do data engineers design what ML models to use for the data? No, so a data engineer actually builds a pipeline which is necessary to ingest data and to basically extract the contents that you need and make the data available for a scientist to actually analyze and infer from it. Awesome. Thanks, Laura. Did I miss any other questions? Please do speak up.
No other questions in the chat, actually. So what roles does Now there's one question from Debbie.
So what roles design? Sorry, I didn't get your question, Debbie.
I think they were asking who decides what ML models to use. That's decided by the ML engineers, right?
Yes, yeah. So the person, like I said, there is. Okay, that's what you mean. Okay, so Debbie, basically the ML model is, I guess, a combination of the use case that you're trying to address, and also a person who understands the machine learning theory to be able to pick the correct model. And the ML ops or the engineer is the person who makes it possible to run that model.
Sometimes they're also called as data scientists, is that right?
Yeah, so these roles are kind of evolving. So it's,
Yeah.
and as I mentioned, I think in different companies, based on the size, a lot of these roles merge.
Right.
So in an early stage startup, we are highly unlikely to have all of these different roles. You probably have one person who's called one of these names doing everything. So
Makes sense. Any other questions?
awesome. So if there are no other questions, I would like to also give a heads up on the upcoming sessions. So on February 16th, we'll have Harini talking about how to prep for coding interviews. And on the 23rd, we'll have Prachi talking about the system design series. This is the part 2 of 3 sessions that she would be doing. So do tune in. And thank you so much.
I just shared a bunch of useful links in the Zoom chat. So before leaving, like feel free to check them out. And yeah, we also have a link to our LinkedIn profiles, and we also have a link to feedback form. So if you have any feedback for us on how we can improve, or if you are interested in any new topics, please mention it in the feedback form. Thanks, everyone.
Thank you.